Hello everyone and welcome to Handmade Hero, the show that codes a complete game live on stream but has been away for the past 2 weeks because of an office move and a planned power outage in the building, which is, I guess that is exactly as its name implies. A planned power shutdown perhaps might be a more apt term for it, but anyway. We're back, and if I remember correctly from the time when we were programming 2 weeks ago, or 3 weeks ago at this point now, we had our renderer working pretty nicely, but I wanted to go ahead and re-enable multi-sampling just for one of the passes so that we could get rid of some of the jagginess. Because we had sort of we don't really have any need for multisampling now that we do the depth peeling. We don't have any need for the multisampling in terms of using it for screen door transparency, which is what we were using it for before. We have a much better solution for that now that works a lot nicer. But we don't have any way of reducing sort of the jagginess that's inherent in the line drawing for our geometric surfaces. And let me just go ahead and oops, I don't know what happened there. Let me just go ahead and start up everything here. And I will show you what I mean. All right, so if you take a look at what we've got going on here, this is Handmade Hero running as it normally does. And what you can see is, anywhere that there's a sprite or anything, everything looks fine. And the reason for that is that sprites are anti-aliased in the bitmap themselves, right? So the edges, if we look around like where the hero's head is or anything like that, those are all nice and anti-aliased, and that's because the anti-aliasing is kind of baked into the sprite itself. And the actual 3D geometry that we're rendering to show that sprite is just a little card. It's like a little rectangle, right? It's something that looks like that. And we never see the edges of that rectangle because the alpha at the texture at that point is 0. And so we don't have to worry about the rasterization of those edges and the aliasing that might happen along those edges as we draw them, right? That's just not a concern for us because you'll never see those edges are invisible. So the part that is in danger of aliasing, which is the pixel, the textures in the pixel that are within that card, those you can count on the artist to have anti-aliased when they initially paint them, right? That's what that painting process automatically does in Photoshop. As you do the brush strokes, they're automatically anti-aliased, so it doesn't even really have to be something the artist even thinks about. Usually they're just going to have it anti-aliased. If you're a pixel artist, they have to worry about anti-aliasing manually, but they will know how to do that. So that's all well and good, but we do have some geometric primitives in Handmade Hero. Not many, and we probably will not really have much more than what's on the screen just right at the moment, but we do have them. And so if we come take a look at stuff down here, for example, you can see we've got all of these cubes that comprise the environment. We'll be texture mapping these cubes very shortly, in fact, with various textures based on the location that the hero is in. But what you can see is that the rendering of the cubes does have sort of jagged borders, right? And that may be difficult to see because if you're watching at home, the video compression on Twitch or whatever may be hiding some of those artifacts. But if you have access to Handmade Hero source code, if you pre-ordered the game and you run it yourself, or if you just have a high res, if you switch to the source mode in Twitch, you can probably see there's a stair-stepping pattern that occurs right along here. Now I can probably go ahead and make that a little bit more specific. Let me see if I can yeah, there we go. So if we zoom in here, you can see maybe a little bit more what I mean, right? So what we're talking about is this little thing here, and you can see why this occurs, right? when you just draw a straight line in screen space, well, it's based on pixels, because that's the only thing that you can set discretely on a monitor. And so each individual pixel has to be set to something. So if all you did is just draw a geometric primitive without any concern, even if you do it perfectly, which the graphic card does, they get a perfectly measured line in pretty much all cases, you can see that you'll see that stair-step pattern because there's no attempt to smooth the boundary in between them, right? And that harsh edge is very clear. Now, if you contrast that to, for example, what happens in something that's anti-aliased, you can see that when we get in here, right, you can see how there's a lot of fuzziness in here that is being used to hide the fact that there's a harsh line there. And that's, again, just the artwork being created in that fashion. You end up getting a much smoother result. And it's a much more pleasant thing to look at. Right, it's like when we actually zoom out to the full level, which I'll be honest, I have no idea how to actually do. 100%, there we go. The hero looks nice and clean and smooth, and you don't notice those. It looks much more natural, whereas everything that was drawn as part of those cubes anywhere looks very harsh and angular. Now, there's two, processes at play here, and only one of them is the one that really concerns us now. The first process that's at play is just general smoothing. And that's something that the artist can be doing in addition to anti-aliasing. It's not technically really, I shouldn't say technically. Anti-aliasing, obviously, is just a broad term that's applied to trying to get rid of the artifacts that occur when you have too few samples to represent a particular function. And in this case, that's just pretty language for saying, well, look, if we had such dense pixel arrays on monitors that your eye could literally not see them at all, right? So the pixels were so tiny that your eye couldn't make them out in any way. Then, at some level of density, if you imagine that these pixels are one, atom wide or something, your eye just has so much less fidelity that you would just draw regular lines, that they would look infinitely smooth to you. You wouldn't be able to see any jaggedness because the resolution would be so high. And someday monitors might get to that point, I have no idea. But in the meantime, monitors have much less resolution than your eye can discern. Your eye can discern the pixels themselves fairly easily on today's monitors, especially at a resolution like 1920 by 1080, which is a very common resolution for a game to run at. And don't forget, 1920 by 1080 may be stretched onto a 60-inch monitor, or television, I should say, in the case of play in the living room. And so you're going to have these big old pixels staring at you in that case. So again, there's two ways of combating that. One of which is analytical and one of which is just purely aesthetic. The purely aesthetic one is, an artist may decide to just fuzz up an edge, right? And that is not a mathematical process. That has nothing to do with signal processing. That has nothing to do with analyzing the coverage or across pixels or anything. It's just them making it smoother so it looks better, right? And that's not what we're going to talk about here. We're talking about the analytical kind of anti-aliasing, which is to say that if we take a look here, how do I get out of this? There we go. If we take a look at an edge like this one in the center here, what we could say about this edge is that, well, we know that the edge actually represented something that was, not necessarily infinitely precise, because we are talking about floating point numbers in a machine. But we certainly knew more about it than just what we've shown here, right? And the reason that we could say that we were more precise than what is shown here is because this edge actually started somewhere sub-pixel, right? We knew a floating point location that is not constrained to the 1920 by 1080 grid that was in here somewhere. And we knew that that line sort of passed through this pixel, and it probably did pass through this pixel a little bit, just not enough to cover the center of the pixel, where the graphics card typically, uses the center of the pixel to determine whether that pixel is in or out in terms of rasterization. So what we want is the more analytical version of anti-aliasing here, which is that as we go through pixels, based on how much of the line, or the side of the primitive that we're actually drawing, how much of that is encompasses each individual pixel, we want to blur those pixels such that a little bit of the primitive color contributes there, and a little bit of what was there before shows through, right? And again, because we are using a Z-buffered rendering scheme, that means we don't sort the primitives in order. So it's a misnomer to think that we can do something like drawing things on top of other things or whatever else in a normal scenario, because the Z-buffer is what's doing the sorting. But in our particular case, we're using a depth peel rendering technique, which people who have been watching the series know how we're doing that. And so we actually have two options for how we could handle this. To be completely honest, I'm not exactly sure which one we would want to do, but I'm probably going to go with the multisampling one. Let me explain what I mean. So normally, if you just have a Z-buffer rendering technique that just does a single pass and you draw your geometry, then what you have to do is you have to turn on what's called multisampling, which we've already covered. If you're not familiar with it, go back and watch the episode where I cover it in more detail. But basically what it is, it just takes more than one sample per pixel for when you're drawing. So it's basically oversampling the screen. And it has ways of doing that more efficiently than if you were to just literally render at a higher resolution. So it can get more quality out of the same amount of work than doing something like that than doing a high-res render and then blurring it down. For example, it can jitter the samples, which produces much nicer results. And it can also do shortcuts where it knows, for example, if a particular pixel is entirely covered by one piece of geometry, it can just only do the work for covering it once, right? So it can do sort of short circuits to the process that actually save a lot of work. So there's a lot, like I said, there's a lot of options there. My allergies have been awful lately, by the way. As those of you who watch the series know, I've been blowing my nose continuously. It's the worst. So turning on multi-sample anti-aliasing is probably what I'll do, just because it's the most straightforward and I think might be what we want. And we've already done it before, right? We already tried it one time for other reasons, and we decided to go with depth peeling instead because it was much better quality for what we were trying to do. But in this case, we could imagine a technique that was slightly different. We could imagine a technique that did rasterization of all of our primitives at their maximum boundary. So normally what happens, again, is you just get that centroid rasterization. And that centroid rasterization basically says either the pixel is in or out based on whether the primitive encompasses the center of that pixel. What we could do instead is switch the rendering rule to say that if the pixel is covered at all, right? So if the primitive touches it at all, then we want to render to that pixel, and then we let the depth peeling algorithm handle the blending of those, right? Because we're already doing that depth peeling. And the only reason I would say not to do that is because I don't know how many graphics cards support changing the rasterization rule in that fashion. I suspect that that's too new of a feature. I'm not really sure. We could take a brief look to see, but I'm pretty sure that's let's see, OpenGL rasterization rule change. Let's see. Let's see. Let's see what this is. So this is not, I don't think, what we want. Here it is. That's what I'm looking for. So you can see this is the exact thing we wanted. So it's called conservative raster. And so if we were to use something like this extension, right, then what would happen is we could tell it that we want to fill all pixels touched by, a primitive, right? So you can see here, this extension adds a conservative restoration mode where any pixel that is partially covered, even if no sample location is covered, is treated as fully covered and a corresponding fragment will be shaded, right? And that's what we want, right? It would call our fragment shader anytime the primitive passed through that pixel, even if it would not have normally been rasterized under the normal fill rule, right? Unfortunately, like I said, I don't think this is the kind of thing that's mainstream enough. Let's find out. So I don't even know if it's supported on AMD. Maybe it is, maybe it isn't. Anyway, I'm just tossing that out there so you know that was an option. This graphics card, this is an incredibly old machine that we use here on Handmade Hero. This graphics card was made, this extension is dated 2015. This graphics card, I think, was made in 2009. I'm not 100% certain if I know exactly when it came out, but I think it's 2009. So it definitely won't have anything like this. And so that's why, even though that's, to be honest, probably the most straightforward thing for us to do and probably would be the most efficient as well, I think we just can't count on that being available in most places that we're going to need it. And so I think we're going to have to go with the more traditional approach, even though it is going to be a little less efficient and adds, an extra step to our rendering process that we don't actually want to have. But that's just the situation. So let's just take a look at how we're going to do this here. It shouldn't be too complicated, but again, because it is dealing with OpenGL and graphics cards, it may take a long time to get working, just because it's always very finicky to deal with these sorts of things. You can't step into the graphics driver, so you can't step into the graphics card's internal logic, so oftentimes it becomes very difficult to determine why something is wrong when it's wrong, as you know. We've been very lucky on Handmade Hero. Strangely enough, we have not really had too many real hang-up bugs with the graphics card, but there's always a first time, so anytime we're going to be doing graphics card programming, I always want to make sure to mention that. Even though the thing we're doing may be very simple, you may be in for a rocky ride. So, if you remember how this is working currently, it's very weird, by the way, after 3 weeks to come back to such huge text. Normally when I'm programming, the text is so much tinier. I always forget on Handmade Hero it's so huge. It's like, oh my god, I can barely see any of the code. But anyway, so here, if we take a look at how this works, where is that frame buffer? There it is. The way that we were doing things is we've got this create frame buffer call, and we're creating a bunch of frame buffers that we use for depth peeling. And right now what happens is we create a couple different depth peels, and then we blend those together. And that's our way of getting nice kind of anti-aliased sprites. And I was really surprised. I'm sure people have done this before, but I was surprised I'd never heard of this. I kind of just thought of it as we were doing Handmade Hero, and we were not getting the results I wanted from multi-sampling. And I was like, what if we do a depth peeled approach? I I've never heard anyone advocate a depth peel approach for sprite rendering, but I tell you, I really like it, and it seems to be a pretty great way to get really nice sprite compositing without having to do the sorting at all. And it allows you to do a lot of special effects and have things like fade out just work, and you don't have to sort your transparent objects at all, which is nuts. I mean, it seems like a really good way to use the GPU resources that you're inherently typically not using in a 2D game, because in a 2D game you don't have to do as much work as in a 3D photorealistic game. If you take a look at something like Battlefield 1 or Doom, the latest version of Doom, not the original version of Doom, they just require a tremendous amount of GPU power, and gamers have these machines capable of processing all of that. And when we take a look at a 2D game, we're like, well, where are we going to use that GPU power? And we typically don't. But this is a pretty good example of a way you could use it. You can use the extra GPU power to do a bunch of depth peels, and then you can have this really nice compositing. So anyway, I'm surprised that I haven't heard more people advocate that. But maybe just because all the graphics programmers are busy writing 3D engines, that's probably why. So anyway, 2D probably isn't that interesting to them at this point, right? They're too busy doing like voxel cone tracing or something like this. Anyway, so if we take a look at what was happening in our source code here, we have this create frame buffer call, and we left in the ability to create multi-sampling. So you can see here, we have the ability to create a multi-sampled frame buffer texture. So if we want to, we can do a pass that has a multi-sampling turned on, and that does a resolve of that pass. And I don't know, I think we unfortunately already deleted the code. Oh no, we didn't. So we've got the blit frame buffer code here too, that we used when we originally did our frame buffer compositing too. This was not frame buffer compositing, frame buffer resolve. So the thing that takes the multi-sample buffer and turns it into a regular buffer that has only one sample per pixel. That's this call right here, and that is great because that means we can just use this code again and be on our way. So all I want to do here is take exactly the same pipeline that we are using at the moment, but change it so that when we initially render the first, the closest depth peel, right? So the depth peel that's the closest to us, which is the first one. That one, since it will have the hard edges on it, I just want to see if I can take that one, render just that peel with multi-sampling, blit it down to a regular buffer, and then do the rest of the depth peels the same way. So I'm essentially just literally taking and compositing the multi-sample, that one first multi-sample slice, down to a regular buffer, and then letting the rest of the process repeat as normal. So I'm not suggesting that we do multi-sampling on all the buffers, and the reason for that is because it doesn't seem necessary. Remember, our depth peel is taking pixels that are like stepping backwards through the depth buffer. So the first thing you draw is the one that is the pixel that is frontmost to the eye. Then everything you draw and subsequent depth peels is behind that pixel. So in my mind, that means that the jagged edges are going to be primarily in that first depth peel, because everything else has to be something that was behind one of those jagged edges, right? And so the chances that you could tell two jagged edges that pass through each other in some weird way, you'd have to be able to tell that that jagged edge was jagged only in that one pixel where it's eclipsed by something in front of it partially, right? And that doesn't seem too problematic. Now, that doesn't mean that it's not problematic, because you could imagine a circumstance in which you would see it. For example, where you would see it is where we have transparent particles. If a transparent particle passed in front of like a line one of the primitive lines, that would be that would still be jagged, right? So if we wanted to eliminate those artifacts as well, we could multi-sample everything. And so that's another option, and probably one we would want to also allow. And so what I would say is, I don't know that there's any real reason to ever multi-sample the compositing phase. So when we composite our depth peels together, I don't think there's any reason to keep multi-sampling at that point. That may just be excessive. But we may want to allow the user to specify, or rather the settings of the game to specify how many multi-sample passes we do. So depth peeling can be done where it's like, how many depth peels do you want to do? And then it can also be how many of those depth peels should be multi-sampled versus how many are just straight one-to-one pixels. All right, so let's take a look at what we would have to do here. So we know where our depth peel occurs, right? Our depth peel is right here. So when we do our render group stuff, here's us doing our rendering. As we go through here, we, every time we hit this code path where we do the end peels, we know that we've finished one. So if we wanted to, every time we finished, we could do that blit resolve, right? And furthermore, when we're at the start code right here, when we're at the start code, we could also, at that point, do one too. We could, if we want to do something at that point that was like switch to a multi-sample buffer if we're not already on one, or other things like that. So I'm not sure, like I said, I'm not really sure how we want to do this, and I'm also not sure if there's any value into persisting the multi-sampling in through the compositing phase. So let's start, I guess, with the simplest thing to do. That seems like it makes the most sense to me, because yeah, like you can see here where we do our, let me go ahead and load these both up at the same time. Here is the final sort of composite that we do. So you can see here we basically do our stacked shading here, and yeah, we don't really need, this is just straight alpha blending, right? It's just alpha blending one on top of the other on top of the other. And so one question that I have here is, if the GL blit frame buffer call actually had alpha compositing built into it, so if you could do a GL blit flame buffer with blending enabled, that would probably be the cleanest way to do this. We'd just loop over, and instead of ever running this shader at all, we'd just do GL blit frame buffer for each frame buffer back onto the main frame buffer with alpha compositing on. But I don't know that there's any way to really do that. So I don't think we can. I think blit flame buffer only does copies, but don't quote me on that. So let's see here. Blitfed transfer is a rectangle. Yes, it's just a pixel transfer. So it's not gonna go through the blending buffer. It's not gonna go through the blending algorithm at all. So that's, there's really nothing we can do about that. So again, we're forced to kind of think about this from the standpoint of when we actually go to composite these, we probably want to do something a little smarter. Now, I am loath to create a separate buffer just for mixdown, but that seems like what we'll have to do. Meaning, what we probably need to do here, if we're just going to go whole hog on it, is in this OpenGL frame buffer where we've got frame buffer handle, color handle, and depth handle, we would have to have one more handle here, which is the like, you know, composited handle or something. I mean, or resolved handle, right? The thing which takes the texture that's been multisampled and turns it into something that hasn't been multisampled. We need a place for that to go. And so if we want to do the composite in one pass, which maybe we don't, but if we do, then we would need to do it that way. The other thing we could do is we could read directly from the multisample buffer in the shader. The problem with that is that I don't think there's any way to actually read from a multisample buffer in a shader without knowing how many samples there actually are and looping over them, which could be a lot less efficient than letting the graphics card do its built-in resolve, which knows exactly how to do it the most efficient way. So I am a little nervous about going that one as well. So just thinking about it, I would have to say, like, I guess let's try the more straightforward one first, which is GL-uint resolve handle. And then in here where we are doing our creation, so where we do our creation, we're going to want to put it in here. Now, I think, oops. One thing I do want to do, and I kind of meant to do this before, is the filter type clamp to edge stuff is always the same for any of these. And so I probably want to say in here, set default frame buffer texture parameters. I probably just want to grab these and put them there. And I'll just take that filter type and I'll pass that in. But other than that, it just works, right? And that way we don't have that duplicated in those two places, so if we want to change those parameters, we can later, right? Similarly, we could look at this slot 2D multi-sample bit here. You can see that these two are basically the same as well. The only difference is the setting for, right, like what the component is. And that's really it. Everything else is exactly the same. So we could actually do that as well. We could say create frame buffer texture, like that. And we could just pull this whole thing out here. Maybe I do it like this. And maybe I'll call this frame buffer text image, like that. So yeah, so in this case, we just need to know the slot. And then we need to know the format that we want that texture to be. So that's going to be, you know, this right here. And I guess what's a little bit confusing about this is the default frame buffer texture format has that sRGB, that weird sRGB problem. I forgot about this is going to cause us a little bit of an issue here. So for whatever reason, this card cannot do sRGB rendering with multi-sampling on, which is very strange and supposedly not even how it's ever supposed to be, but it just is. We don't actually know why the driver refuses to create a surface in that way. So yeah, we have the solution to that, which is we do the squares and square rootings. And so we can force it into that mode if we want to, and that's fine. But I forgot about that. It means that we will not be able to test the rendering perfectly on this machine because, of course, we can't test multisampling and sRGB together, which is a bit of a bummer, to say the least. Well, what are you going to do? Anyway, so yeah, looking at this though, I guess now that I think about it, pulling this out is a little bit trickier because when we want to do the depth version, there's that switch that happens here where, you know, you're sort of picking a different one of these in either case, which would mean that they would have to pass the both things in that they wanted, both this and this, because both of those two things will change depending on the circumstance. On the other hand, I guess they only need to pass one of them technically, because this part right here is not relevant since we only pass a 0. You could really pass anything you wanted for these two, presumably, and it wouldn't be a problem. So we really only need to pass one thing in, and that thing would be this format. So I suppose that's actually fine. All right. So that's all good. All right. So there's the format that it's going to use. And what I could do here as well is I could preserve this a little bit and just say format, and look to see if it is a depth format. And if it is a depth format, pass a depth component just to make sure that the driver doesn't complain. So there we go. And we'll just grab out that the wrong way. So we'll just look to see, hey, are they, you know, is this the depth one that they're creating? If it is a depth one that they're creating, then let's go ahead and give the driver the right information about what we would be submitting if we were submitting, just in case it does error checking there and thinks things have gone horribly wrong. All right, so we've also got a width and a height, and we've got a slot. So what we could do here, in addition, is we could kind of bundle all this together and say, well, the gen textures part of it we could do too. So all of this could go in here as well. And then what would happen is we'd just have a return value, right? We'd have something like this. And then in theory, we can replace all of these pieces of code with this. So here, when we're creating the color handle, we can just say, why don't you make us one of those, please? Wait, why is the slot passed the second time? That was just silly. So in theory, yeah, all of that can go away. And then we really just have this. Now the filter type has to get passed in as well, unfortunately, here, because, again, that's based entirely on the flags. Now, I suppose we could pass those flags in and have this do the switch on the filter type. And yeah, I mean, that could in theory also be something that would, instead of passing the slot, it would just do that automatically. So I don't know, like, yeah, maybe that's a good idea or not. I don't know that it is, though. Because we're going to need to create both for the multisampled, one that is multisampled and one that's not. So at that point, that seems less good. So I'm going to go ahead and say, let's get rid of that and put the filter type in there so that we have slot, width, height, format, and filter type. And then I think that should be good to go, right? There we go. All right, so we can replace this one as well, exactly the same way. Here's the result depth handle that we want to set. So we just want to do frame buffer text image for this one as well, with all the same options, except now instead of passing the frame buffer texture format, we actually just want the depth component version, right? And we can get rid of the rest of these. And now we've got a lot less duplicated code in there, which is nice. Easier to read, and also has the advantage of if we want to change it once, we know how to do it. And of course, as you may suspect, the reason that I did that was because now we have to create a third one, and I felt like copying something 3 times definitely gets to the point where it should be pulled out into something reusable. So what we want to do now is say, well, okay, in the case where we're going to do a multi-sampled frame buffer, let's just create a resolve buffer specifically for that. So the resolve buffer is going to be the same as the color buffer, right? The only difference is it's not going to be multi-sampled. So this slot here is always going to be GL texture 2D instead of potentially being multi-sampled. Other than that, it's going to be exactly the same, right? There's going to be no difference between the two. It's going to be identical. Yeah, this case we don't ever need to attach it to a frame buffer. Well, I guess we probably do. We probably have to create yet another frame buffer here because we're going to have to basically resolve it to something. And without a frame buffer, we are unable to resolve it. So we need 2 things. We need resolve frame buffer handle, and we need resolve color handle, right? So what we want to do here is check the frame buffer for completeness at this point. And then this one also will get checked for completeness. For good measure, let's go ahead and turn this off. So basically what I'm doing here is I'm saying, okay, this is creating the initial frame buffer, and then if it's multi-sampled, I need to create another frame buffer, right? And that frame buffer is used for nothing other than the resolve. We do the resolve color handle the same way we did the other handles. And then what we want to do is attach it to this frame buffer. Again, not using the slot because we don't want it to be multi-sampled. We want it to be texture 2D always. And now we have a frame buffer we can use for that purpose, right? So the first thing I'm going to do is run this without the multi-sampling to make sure that that still works okay. Right, because we made some changes there, and I want to make sure that we don't have any issues with it, right? And so now what I'm going to do is try to turn on the multi-sampling, and again, unfortunately, that's going to break some stuff. Now, what we need to do here is we still need to do the testing that we were doing before when we init OpenGL. So this allow GPU sRGB I guess we have that off permanently. So I guess that won't create a problem for us. Oh, right, we did turn that off because of the sRGB inaccuracy, because our sprites are not currently sRGB, they're actually squared. So I guess that's fine. So I guess we're okay. Yeah, all right. So everything should work peachy then, because we're actually doing the sRGB approximate sRGB handling ourselves, so that's pretty good. All right. So what we want to do now is we just want to go ahead and implement that resolving pass that we were talking about before. So if we go to our create frame buffer code here. You can see here's our depth peel flags, right? And those depth peel flags are, I guess, not set with multi-sampling enabled. So what's interesting about this is, I guess this entire time we've sort of been... I see. So there we go. Again, this is the problem of not having programmed on this code base in previous. I forget that we set ourselves up for this. All right, so we do have this all in place. We have the multi-sampling hint there, and the multi-sampling hint will basically say, oh, hey, how did you want to process multi-sampling in this case, right? Did you want to use it or didn't you? And that's what we want. So I think that'll all work good. And remember, when we do free frame buffer now, we're going to have to be a little bit more careful because we're going to have to free the rest of this stuff as well. So we've got our resolve frame buffer. And we also have our resolve color. Is it resolve frame buffer handle? Yeah, there we go. All right, so that's all good. And now we will create a multi-sampling surface with the resolution, with the resolving frame buffer and all that good stuff. However, we are not actually resolving anything at the moment, so we shouldn't see anything. Oh, it looks like we've got a error to look at here. OpenGL did not like something about what we did. GL bind texture has generated an error, invalid operation. So it looks like it's trying to bind. Oh, well, yeah. So this is actually expected. I just didn't think of it. Again, because when I said we won't see anything, that is actually true. But there's also an error that will be generated. So you know, if we ignored the error, we would see a black screen. But the error that's generated specifically is that, again, you can't render from a multi-sampled texture as if it was a regular texture. Remember, OpenGL has a bunch of filtering rules that are set up and are specifically defined around having a regularly sampled texture, one that's sampled in a grid, and it expects that, and that's part of the rendering process. A multi-sample buffer does not work that way. A multi-sample buffer is a series of scattered samples. They're jittered, and so sampling from that is not defined rigorously, at least not in OpenGL, or not in the vanilla case. Now again, you can sample from these yourself, so if you wanted to write your own sampler that took lookups into the texture and did some kind of averaging based on the distance from the point being sampled or whatever else, you could do that. It's just not defined by default. And so if you try to bind a multi-sample texture as a texture to read from, it's going to give you an error. And that is, again, specifically why I created those resolve buffers. So what we want to do here, I suspect, is when we do that bind texture here, I want to basically switch on which one I'm going to use based on whether multi-sampling is enabled. So basically I'm going to do something like this. Let's first grab GL frame buffer. I'm going to go ahead and grab out that particular buffer. And then what I'll do here, actually, I guess, is I'll just say, oh, okay. Right. I guess, now I think about it, we're also missing the depth buffer. in some sense, I probably could have just created 2 different frame buffers. That might have been smarter now that I think about it. Created 2 frame buffers, one multi-sample, one not. You know what? Hold that thought, because I think that's what I would rather do. So let me undo that change. I think that's not necessary, right? I think what we could do is say, let's just pretend that that is not there. Like so. This should run just fine, because now we're not creating... Oh, well, that's a lie. I have to turn off multi-sampling. There we go. So what I'm going to do is I'm actually just going to go in here to where we create the peel buffers themselves, which is right in this this group right here. And I'm just going to create a resolve series, right? So every time we create a depth peel buffer, what I want to do is I want to basically say, if we're multi-sampling, I want to create a corresponding depth peel buffer without the multi-sampling, right? So if we're multi-sampling, then create a depth peel resolve buffer, and do it with the same flags, but I just don't want the OpenGL frame buffer multi-sampled flag, right? So this basically creates a parallel array of depth peel buffers that we can use specifically for resolving our stuff. So that, for when we go through free frame buffer, we're going to have to do the same thing again to free all of our resolve buffers. But other than that, it should be the same. So that's pretty great, because that's much cleaner than what I was going to do, where I was just over complicating things by making it so that there was a whole other set of parameters in there. So let's leave it like that. I think that's much better. So anyway, does anyone know why is my little it's day 335. My little head card is not there. I'm gonna put up a little something in that corner to remind me that it's not there, because I'll constantly be romping on it. All right. In fact, let me switch over here to avoid it. All right. So let's take a look at what happens now. So I'm going to have the same problem if I don't do anything change it, presumably, which is that I'm trying to bind a buffer that I can't draw from, right? I'm trying to bind a texture. So what I need to do now is actually do that resolve. But before we're going to draw from it, I have to actually resolve it. And so in theory, what I could do is just say, well, okay, this is what the peel buffer would be, but if we're multi-sampling, then the peel buffer is actually going to be coming from the resolve pass, right? And now that should actually work properly in the sense that we shouldn't get the error, because that is a texture you can bind, or not. But and I'll have to figure out why not, but we won't see anything yet because nobody's writing to it. What is the error here? Oh, so yeah, again, that's also fine. Those are just the 2 places that we read from those buffers. So here's the other place we read from those buffers, and again, so you know what, and 2, if we want to do that, meaning if I want to read from in 2 places, maybe I'll just make this a little utility function, so you can just call it, and you'll get the right one. Something like get depth peel read buffer. right, as opposed to get depth peel write buffer, because the writing will always be the same no matter whether you're multisampled or not, but the read buffer will switch. All right, so in order to do this, all I really need to do is pass whatever the index is. So this kind of goes away here. And so now anyone who's calling that can just call it directly and not have to do any thinking about it at all. Same is true here, right? So this is looking for that color handle. And so what we can do is say, all right, wants to get a peel index here. So here's that peel buffer, right? And now in theory, no one should be drawing, should be setting as a texture the multi-sample buffer. And so now we're to the place where I would expect to be, which is black screen, because we're drawing, we're creating our depth peel buffers ostensibly with multi-sampling, but we're not actually using them because we never resolve. So we're drawing out of buffers that never get anything drawn into them. So now what we want to do is do that resolve. The other thing I would point out is you'll note we don't ever want to actually clear these. So it's okay that we're never doing this, because those resolve buffers are never going to get used for anything other than just splatting the contents of the peel buffers that are multi-sampled, just drawing them directly down. All right. So let's take a look. When we get to render entry end peels, that means we have produced a peel buffer. And you can kind of see here, we're about to do like a binding in one way or the other. Either we'll bind back to the original, or either we'll bind back to the original, or we're going to bind to one of the subsequent depth peels. So what I might say here is when we get to the end of our depth peels, then what we probably should do is actually use the read buffer call. And the reason I say that is because after the depth peeling is done, we don't really want to be doing multi-sampled rendering anymore, right? Because we're sort of saying we're doing debug passes or UI or something that we didn't want to use multi-sampling on. So in the OpenGL bind frame buffer bit here, I'm just going to say let's go ahead and bind the peel buffer that corresponds to slot 0 in that case. And then in here, when we're actually coming through render entry end peels, in any case, no matter what pass-through we've completed, here is where I would like to do that resolve. So what I want to do here is, before I bind whatever frame buffer we're going to be drawing to for the next pass, I want to just do a quick bind where we bind a read buffer and a write buffer in the case of multi-sampling. So if we are multi-sampling, we know we have to do a smush down here. So I want to read from the depth peel buffer and write to the resolve buffer, right? And I want to do whichever one is the one that we're currently on. So when we hit end here, I want to do, like if we just drew to peel index 0, I want to do 0, right? So then we're going to do this. We're going to do the blit. Unfortunately, this is the wrong stuff for the blit, because this was for screen blitting, which is not what we want. So we actually want something that looks like this. We're just doing a render blit, irrespective of screen coordinates. We're just doing our render back buffer, right? And furthermore, we need to do a resolve of both the color and the depth buffer, because we're going to be reading from the depth buffer as part of the depth peeling pass. So I believe that's all we would probably have to do. Famous last words in graphics programming, so take that with a grain of salt, but I believe that's mostly what we would want. And now we'll let OpenGL tell us what's wrong here. So the error message is must be GL nearest. You know what? And that's actually fine, because these should be 1-to-1. So we actually don't want any filtering on here anyway. So in theory, that should be fine. That's probably better. Oh my. I can't say I have any idea what happened to the frame rate there. Everything appears to be working, but it definitely appears to be much slower than we would like. I'm also seeing some weird artifacting in places that I have no idea why there would be artifacting. So I think we've got a little more work to do. Like there's super strange fringing, yeah, on the side of things. I mean, we are getting some of the anti-aliasing, but yeah, so I think part of the problem is the depth buffer anti-aliasing is maybe the problem with producing the depth buffer in an anti-aliased fashion is maybe that we're not getting what we need to get in terms of how we would depth peel, right? What's interesting about that is, yeah, I mean, we could just keep doing, yeah, That kind of suggests to me that we would have to do the whole depth peeling process. That kind of suggests to me that we'd have to do the whole depth peel process in multi-sample, which I gotta say, I feel like it's just going maybe a little bit too far. We're gonna have to think about this. I'm gonna take a brief screenshot here because I do want to look at what the results look like. So, you know, in terms of getting the anti-aliasing on the edges, it does look like that produced a reasonable result in some circumstances. It definitely didn't produce a reasonable result in some other circumstances, like you can see here, how it's actually darker than the gray there in some weird ways. And that's probably, again, because of the depth artifacting there. So yeah. So what should we do here? I'm not sure. Again, you know, what I would really like to do is not use multisampling at all and just use conservative rasterization. I'm trying to think if there's some way we can sort of approximate conservative rasterization by making our primitives bigger than they need to be and then doing the rasterization ourselves. The problem with that is we would have to do it in screen space because we don't know until we start, until we actually project the stuff down, how big they're going to be, how big a pixel, how big we'd have to move them to rasterize a pixel. Yeah. And you can see when it is actually working properly, you do get nice results there, right? That's much more pleasant than what we were seeing before. Certainly a lot nice and smooth. Well, I don't know what to say. I mean, what we could say is, you know, we could just try doing the whole thing. Instead of doing the resolves, just do the whole thing in multisample. I don't know that that's the smartest thing to do in the world. but we certainly could try it. And again, most of the reason why that's complicated is just that the multisampling is, only lightly supported in the pipeline, and we have to sort of manually access those samples very specifically. Well, I guess here's what I'd say. Let's at least try it. I mean, you only, pound YOLO, I guess, in this case. So I guess, we'll give it a shot. So essentially the problem here, if we want to do everything multi-sampled the whole way down, is that we need to read from those buffers in a specific way. So let's go ahead and grab that quick reference card that we've used before. I'm hoping this is available in 3.2, so I don't know if it actually is. Where are the Texel? There we go. So, let's see if it's on here. I actually don't see it on here. So if we wanted to do that, we might be required to use a higher level of shading, actually. Take a look here. Oh, you know what? No, I take that back. This is just me looking for it in the wrong place. So technically that's not true. It's really just that you have to declare the sampler as a multi-sampler. Yeah. Okay. Sorry, that was just me spacing on that. It's early in the morning for me here. So this is actually all we needed. Access 2D multi-sample texture, right? And that is, luckily for us, in 3.0. I was going to say, I thought it was in there. So since Sampler 2D MS exists in there, we should be able to do what we were doing. Oops. We should be able to do what we were doing just fine, hopefully. That's not what I wanted. I just want the spec for it there. But that may be harder to come by. Let's go like this. GLSL spec 3.0. Come on, people. Okay, there's a page that has all these specifications on them. Bring me to that page. I don't want the PDF, I want the actual... Here we go. There it is. This is what I wanted. So I should be able to read OpenGL Shading Language 1.5 specification, 1.3 specification, etc. So let's take a look at this one, right? And let's take a look at Sampler 2D MS. So it looks like that was added after. Let's take a look. Is it in here? Yes. So basically that was added, it looks like, in the change from 1.4 to 1.5. And so we would have to go to 1.5 for that, which is probably fine, right? That's not going to go up to OpenGL 4 or anything, so probably that's just okay. Yeah. And so you can kind of see what happens here when we do a texel fetch. What you do is you can get the sample and say, I want to get a particular sample out of the texture at this location, which should be fine for us with what we're doing. Because we can use the sample value that comes through in the shader, which it will define for us, right? Let me see if we can GL frag sample chord. Where are these defined? So here's the special variables that come through the fragment shader. It's got the fragment coordinate, front facing, clip distance, color, frag data, point chord, primitive ID. I was hoping that there was a sample value in there, and you would think that there would have to be in order for this to work, but I don't know where that actually is. Let's see. I'm interested to know if I look at the quick reference card and I look at the shader, the variables that are listed as built-in. Yeah, none of these are specified in there either. So that does make things a little bit trickier for us, because if we just want to say, hey, we need to get this, whichever sample we're shading right now, that's the one we need to get from this particular sample. But I don't see it. Let's take a look at the spec under texel fetch. Here we go. So here's all the texture lookup functions, right? I don't know if any of these are discussed in detail. No, it doesn't look like it. It's not the best spec in the world, if we're honest. Okay. Still not seeing anything that tells me what I want to know. So I'm not sure. I just want to get I can show you what I'm wanting and not getting here. So what I want is inside these routines, right? We've got two places that we actually load from these. So you can see here where we are doing our depth peeling, we do a texel fetch from the depth sampler, and that texel fetch is just like, hey, here's the location to fetch from, and if I wanted to fetch from a multi-sample texture, the thing that's the problem is I need to make sure that I'm sampling from the same sample as the one that I am on. So if this pixel is evaluating sample 3, I want to make sure that I get depth sample 3 from this buffer, right? That's the key. But I'm not sure how to guarantee that that is what it will actually do. And I just wanted some documentation that would be specific about what would happen in that case, right? So what you can see here is that if I call it with a 2DMS, as far as I can tell, you have to pass an integer sample number, right? I don't see any other way that you can sample from one of these. And so the problem is, if I'm going to pass an integer sample number, I would need to know what that integer was for the current sample. But I don't know what it is because it hasn't given it to me anywhere, right? So what I would have expected, and what I am not seeing, is I would have seen inside this the set of built-ins, right? That in the fragment language, in here, I would have expected to see an integer value, like this one, that just said sample. But I do not see it. And so, yeah, I suspect that possibly the reason for that is just because you don't always run the pixel shader on all of the samples in a pixel. Because if the geometry doesn't pass through that pixel, then it's only going to render, if it's entirely enclosed, if it doesn't pass partially through it, then it's not going to call the fragment shader for every sample. It's only going to call the fragment shader for just once and fill all the samples with that value. So I think, I mean, unless I'm mistaken, I just really don't see a lot of ways to do this. I can't think of a way out of this. Really, all we really want is conservative rasterization. That would definitely solve our problem. Unfortunately, that's not really forthcoming. We could turn it on NVIDIA parts, or I guess I don't know. There was a really good page, I can't remember, extension support. I can't remember. Yeah, this was it. Was this it? Let me see if I can ascertain how much support there is for that, because I don't really know. 1% on this page. Let's see if I can look by. Guess there's no way to search for conservative rasterization. I don't really want supported OpenGL versions. I want capabilities. So let's see. NV conservative. So they don't have. These are just the caps bits. How about here? Conservative. There it is. Yeah, so that's like not very supported at all. So we could get anti-aliasing pretty cheaply on any modern GeForce card, it looks like, but that's about all we would get. So let's take a look. And Intel's got its own conservative rasterizer extension, it looks like, too. So yeah, you know, we could get some anti-aliasing with the depth peeling on those, but nah. Not great, if we're honest. Not fabulous. So I do wonder, however, you know, so maybe if we just return to what we've got at the moment, since it does look like going the sampler to DMS route. So first of all, I have no idea what that slowness is at the beginning there. Like what is going on here? I have no idea. I have no idea what is happening with that. That is kind of just nuts. So I don't know if that's something stupid we're doing, or if that's something where we're just pushing the card a little bit too hard, because it is at this point 7-year-old graphics card, which admittedly is not going to be the smoothest thing on the planet. But yeah, just looking at what's going on there, I'm not sure exactly what. I'm not sure exactly what I could do to sort of work around this problem in any meaningful way. I mean, I'm pretty sure we're not doing anything too dumb here. That all seems pretty reasonable. So yeah, I don't know. Presumably we haven't messed up anything accidentally, right? If we turn multisampling off, we're presumably back to running properly. Let's go ahead and... Oops. So yeah, that's all. Everything's fine there. No issues at all. So yeah, I don't know what other approach we could take. I'm thinking of what else we could sort of do there that wouldn't be too onerous. I mean, I assume the problem there is just that creating the depth buffer in the depth peel mode is simply not going to be precise enough at the edges of objects, because you need to know what the depth was at that point for blending, but you don't actually know what the depth was because when you resolve, you will average them down, right? In other words, I've got an edge passing through space like somewhere here where part of the pixel, it's going to be something way behind, and part of the pixel is going to be something up close. I feel like it would fix it if it just picked the closest depth value, but I don't know if that's something I can actually have it do. Meaning, when I do the frame buffer resolve, I don't actually know if there's some way to get it to the... I feel like I could do it myself with some kind of custom resolve. But what I needed to do here, right, is when it does the depth buffer, I needed to pick the maximum value, whichever one would have been closest. So I wonder if there's some way I can do that. Let's find out. Maybe that's something I could do. And maybe that would be enough to get us over the hump. Let's see. filter specifies the interpolation method that will be applied to resize source. It must be GLinear or GLinear. All right. Let's see here. Bit frame buffer. And while we're at it, we might as well bring up the spec and take a look. So here's the spec. Let's look at blit frame buffer. And see if they discuss multi-sampling in here. Hopefully they do. Come on, people. That's what I wanted. All right, so let's see. How do we resolve these? They don't really specify this in this part of it, it doesn't look like. Well, not really getting the information I want. I just want you to tell me if there's any way I could process this and get the maximum depth value. Maybe I'll ask Google. I like that this is the Qualcomm. I feel like there's gotta be a way to do this. I suppose one way I could do it is I could just write the shader myself and do, basically do a full frame buffer blit, the same way that we're doing it to resolve at the end to combine our depth peels. I suppose I could do at that point to resolve the depth as well. But the problem is I need the depth to be the maximum, like the closest depth value that was seen. And I would have thought that that would have been a default operation, actually. because it's kind of what you would probably want most of the time, I would think. But maybe if you're not doing a depth peeling operation, then you don't necessarily want that. But I'm still not seeing anything here that suggests that you could do that. So that feels to me like the only real way that I could do it, would be for us to implement that manually. So basically what that means is this, this operation where we bind the two frame buffers and then do blit would have to be replaced with our own custom resolve. And this right here is our own custom resolve. So really we already have the code for it. We would just need to make that more systemic, right? We would need to make it so that that was something that we could do sort of separately. So if I wanted to do that, we'd be talking about something like this. So here's where the resolve goes, right? And all that code has to happen. I'm going to pull that out into a function just so it doesn't get quite so indented, so I can read it. So if I wanted to do this, again, this is substantively all I really need to do is this exact process, GL buffer data with the fixed vertices, and then we would have to do something here, which is like our multi-sample resolve. And we don't really need to do a for I loop here because we're only going to be accessing just that one texture. And then this code remains the same. So it's a pretty compact operation here, but I don't know, it might be too expensive to do just in terms of how much it's going to cost in terms of shading time. Again, only on this card. On modern cards, it'd be no problem. So if we want to do this, we would basically need to call resolve multisample on like an OpenGL frame buffer from and a to, and then we would need the width and height. So when we bind a frame buffer, we're going to want to bind the to frame buffer. So whatever the basically the target was, we're going to bind that buffer. And then we would say, well, okay, we're going to do a resolve multisample. We want to bind, as the read buffer, we're going to want to bind both the color and the depth handles together. And we would need to be able to fetch the depth value out of the texture. So we'd actually need to set the Z value, right? And hopefully that's something that we'd be allowed to do in OpenGL shading language 1.3. I'm not 100% sure if we can or not. Let's see here. OpenGL write fragment Z. So it does look like you can write to frag depth. I don't know if you can do it in 3 or not, but hopefully we will be able to do that. So we'll find out when we try to compile the program. So yeah, in this case, we have everything set up here, which pretty much looks like what we want. I guess the other thing to think about here, which is kind of confusing, uh, is that we only want to produce sample values. We only want to use sample values that we actually took. Yeah. I mean, it just seems like I'm going to have to go. I'm just not feeling super confident about this, because if we have to do that, that also seems pretty problematic, because we're going to have to do stuff like say, well, okay, when we're doing the depth peel, we look to see what the previous round output as its depth value. And if it's multi-sampling, it's going to have to ignore any depth values that are other than the closest one. It would also have to ignore the colors from those ones that were not the closest one, which I guess is fine. I mean, it might just work. I don't know. It's a little iffy. So I don't know. We'll push forward a little bit. I'll do it. It'll be hard to tell if we've got a bug versus it just doesn't work. But yeah, I mean, I don't know. I guess we'll try, right? So in this case, we have to bind two textures to read from, right? So we need to bind both the color and the depth. Like so. And so we've got the color handle and the depth handle both specified for the buffer we want to read from. So this would allow us to write a shader that could read from the color handle and the depth handle of one of the multi-sample buffers, and then write to some destination, writing both the depth and the color value that we desire. Now, when we do this pass, we don't want any blending of any kind, I think, at this point. But we've got GLBlendFunc 1 and 1 source alpha on, so I think we would also have to, in this case, disable blending. But we always do have blending disabled, it looks like. All right. I guess that's because we're depth peeling. So all of our blending happens in that one resolve shader. So I think that's all good. So this is probably all we really need to do here, and then we just need to write the shader that actually does this operation. So taking a look at the setup for this program, basically it's the same as the peel composite program. But we're going to have two different samplers here, right? So we've got the color sampler and the depth sampler, right? So when we do this compile, this is our resolve multi-sample program. And I think most of this is going to be the same. Now, we don't need the vert color stuff here. I don't know why that's still there. That can go away. Oops. And I don't think we need the vert UV either, because we're only going to be using direct lookup. because you can't stretch. In fact, I don't know why did we have vert UVs in here. I have no idea. It's a good question. Anyway, so we don't need UVs, and we don't need any of this. Basically, we just need a straight pass-through vertex shader that's going to just make sure we get a primitive that covers the whole screen. That's all we really need at all. We don't need anything else, right? So in this case, we've got two of these multi-sample samplers that we're going to use to read from. We basically have no inputs. We just have the output, which is the result color, and then we have to write to the frag Z, which I don't know if we have to declare that writable or not in this version of stringing language, but we'll see what happens. So at this point, I need to use the same kind of texture lookup we were using here. Basically, this is the sort of stuff we need. But we're going to be reading from a multi-sampled texture, so it's going to be slightly different. So we don't need any of this stuff. We may want to do our squaring per sample. So we'll leave that in for the moment. But that's basically all we would be looking at. Now, our result alpha will also need to be computed because we do actually care what the alpha value is for compositing later. And we're going to need a for I loop here essentially because we need to loop over the number of samples. And so in here we probably need an in. That's going to tell us, how many samples there actually are. That's probably a constant we could use that's predefined in OpenGL, but I'm not going to risk it for now, right? I'm also going to make sure we have assume those are what those are normally defined as. I don't really remember. Anyway, so if we have the sample count, and we want that to be, actually not an in, sorry, we want that to be uniform. It's just going to be set in the constant store. What we should be able to do is do a for I loop from our samples. Right, so we just go through each sample one by one. Inside the for I loop, we should be able to sample them, like so. And, like I said, I really don't know how well this is going to work, but we'll find out. So we can get the color, we can get the depth. Like so. And then what we want to do here is, I think we just want to figure out what the max depth is. Now, we probably have to do this twice, unfortunately, because we don't want to sum any color values that aren't the maximum depth, right? Although I guess what we can do, I guess we can be creative here. So what we could do here is closest depth. And I believe our depth values, the way that we set them up, you can see here that we discard anything where the clipped depth, where the frag Z is less than the clipped depth. So that means that lower values are closer, right, to us. So, the closest depth here, I assume we want to be 1.0, which is all the way back, right? And as we go through, we're going to want to compare against that. So if the depth value that we get here is less than the closest depth, then it's our new closest depth. Or the other way to say that would be if the closest depth is greater, right? So that's just a way of picking out what the closest depth is. Now we have to do something with the color as well. Now here's the dilemma, right? We have to figure out what we're going to do with this averaging process. So it's just so janky. So here's the part that I can't seem to wrap my head around exactly. And we're basically out of time for today, so that's good. We probably want to think on this overnight if there really is anything that we can do here. So here's the problem. If a primitive passes through a pixel, then we almost need to just know which parts are part of that primitive. Like we almost need to use the primitive ID or something like that to tell us how to blend together. Because if we just use the depth values, we don't know if two adjacent samples with differing depth values both came from the same primitive and they just happen to be on a slant to the viewer, or whether the depth values are different because it actually represents two separate things. So yeah, I don't know. Even just looking at this, I'm just thinking, this is going to be one of those super nasty things if you did it this way, like the screen space anti-aliasing and stuff like that never seems to work right, where you're always trying to compare depth values and make guesses about what they mean, but you don't really have the information you actually want. Yeah. So I have grave doubts about this. But let's put this in there. Just to leave things compiling. All right. Let's go to a really brief Q&A here. In fact, I probably don't have much time for the Q&A actually. Because I gotta go soon after this, but let's just take a brief gander. I think it will be useful to bind a key to topmost window as there is a key to full screen. Then you will not have to resize your editor for live code editing. Yeah, that makes sense. Also, since I bound the thing key, I'm a happy panda. Warm recommendations. Why S32 for the count instead of U32? Just because S32 is, I knew that int was a thing they supported. I couldn't remember what the syntax was for unsigned ints. I think it's int unsigned in GLSL. And I just didn't want to have to check. But you could use U32 just fine. Could you up the bitrate? It's really hard to watch when there's too much movement on the screen. It gets all blurry and pixelated. Not exaggerating when I say it makes my eyes watery. So I guess I don't know where that's set exactly. I guess that would be something that I'd have to change in my So I guess here's the question. Are you sure that it's not Twitch? Like, are you sure that it's actually me? Do you see the same amount of blurriness if you run it on YouTube or not? At the high at 1080, if you do YouTube 1080? Because I'm not sure which one. I guess I don't know what artifacts in terms of the video you're actually talking about there, but it's either the fact that Twitch is doing that or that the bitrate on OBS is just too low in general. All right, so it doesn't look like there's any substantive questions at the moment, though, so I'm going to go ahead and wrap things up, and we will take a look at this tomorrow. All right, thank you everyone for joining me for another episode of Handmade Hero. It's been a pleasure coding with you as always. If you want to follow along with the series at home, you can always pre-order the game on handmadehero.org. Come to the source code so you can play around with it and do your own experimentation. We also have a forum site you can go to if you want to ask questions, a Patreon page to go to if you want to support the video series, a schedule bot that lets you know when the series is going to be live if you want to watch it live, and an episode guide with a new pretty amazing search feature. I don't know if you guys have seen this, but Asaf Gartner and Chrono Dragon and Miblo and Jurun have all done some amazing work here. So you can actually go on here and search for stuff now. You can just go multi-sampling or whatever. I don't know if I spelled that right. But you do that and it comes up with all the times I've talked about multi-sampling. And you can click right on one of these and it jumps right to the video, which is kind of awesome. It's by far the best way to find stuff in the series. It's so good. I highly recommend it. All right, that's about it. I will be back tomorrow when we'll take another look at if there's anything we can do with that multi-sampling. Before I just say the heck with it, we'll leave it as it is. All right, thanks for joining me and see you back here tomorrow. Take it easy, everybody.